These are the materials you need to complete this lab. A set of 9 cubes with different materials, a digital scale that you can read on grams, a beaker with water, a graduate cylinder, a ruler in centimeter, a calculator, and some paper towel. You also need your data table to record each mass for each cube, the volume, calculate the density, and identify which material are those based on their density. First, select a cube and place on the scale. Record this value in grams on your data table. Calculate the volume of this cube by measuring each side. This is 2.5, 2.5, and 2.5. So the volume of this cube is 2.5 times 2.5 times 2.5. That's the value. Now, calculate the density of this cube by dividing the mass for its volume. So the result is 9.3. Then use this range with different materials for density and identify this material. So in this case, is in this range. That should be copper. And record the identity of this cube. Repeat the same procedure for all cubes. Find its mass in grams and the volume in cubic centimeters. One notice, all cubes, they have the same dimension. So it's safe to say that all cubes, they have the same volume. Now that I recorded all masses for all cubes, I'm going to use my calculator and calculate the density for each one. Now that I calculated all the densities for each cube, I'm going to try to identify using this reference paper. So this is the order that I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have here up to 10 as well. So this is my cube number 2, and I have a density of 8.2, and I see here brass. That's the range, brass, but I know this is not brass. So what I'm gonna do, I'm gonna put this back and I'm gonna be working with the next one. So my next one, number 3, is 8.8, and if I look here, it's brass. It's yes, these look like brass. So I will take this one. My number 4 is, density is 1.6. So here, this is probably PVC. Number 5 is 1.2. 1.2 here is acrylic. This is number 6, and my result is 2.9. So after doing some correction, so that's the one, aluminum. This is my number 7. My number 7 is 1.2. So I know that it's not acrylic. The only one that is closest, the closest one to this, to 1.2, will be nylon. Number 8 is 0.5. I would say it will be pine. Number 9 is 0.7. I would say it will be oak. Number 10 is 0.5. I would say it will be poplar. Honestly, those 3 wood one is very hard to identify who is who. Between pine, poplar, and oak. So we still have one blank spot here that we need to figure out which material is this. The only one that is left in this list is steel. Here is from 7.6 to 7.9. In my calculation I got 8.2, but I will say this will be my steel and feels like it is. So now I have completed my table. Some I could identify really well, some maybe because we are kind of familiar with and we did a process of elimination, but it's complete, the table 1. Now we are going to use those 3 materials to calculate the density of water. First, place a empty graduate cylinder on the scale and find its mass, 37.6. Then place a quantity of water that you can read in milliliter. Any amount of water would work for this experiment. In my case, I have 50 ml. Now I place the graduate cylinder with water back to the scale and I record this value. Now I need to subtract the mass of the graduate cylinder in water minus the empty graduate cylinder. So this is the mass of water. For the volume, I'm going to record my reading on the graduate cylinder, which is 50 ml. Please notice that ml, milliliter, is equal, 1 milliliter is equal to 1 cubic centimeter. And we need to use cubic centimeter because you are going to compare with the density of the cubes, and we calculate in cubic centimeter. So to have a consistency with unit, I'm just gonna go ahead and for the result of the density of water, I'm going to write in grams per cubic centimeter. So I have this unit that is consistent with this unit right here. Now I'm going to divide the mass of the water, 49.7, by the volume of this water, which is 50. This is my result, 0.99 grams per cubic centimeter, or also we can say 0.99 grams per ml. Those two are equivalent, are the same. Now the part 3 of this lab is kind of compare the density of water with the density of various cubes, various materials. Now let's answer those 2 questions. Which material cubes do you think will sink in water? So the density, the materials with density higher than the density of water will sink. So in this case, it will be copper, steel, brass, PVC, acrylic, aluminum, and nylon. I'm going to indicate just 1 through 7, which is all the material from this table, from 1 up to 7. They are all going to sink. Now the materials that will float are the ones that have the density of water, the density less than the density of water, which will be pine, oak, and poplar. So materials from 8 to 10, pine, oak, and poplar. To test this hypothesis, we are going to use a beaker with water, and you are gonna drop 1 cube into the water to see if it sinks or floats. You are going to repeat for all 10 cubes. I'm going to try those cubes that I said I will float because the density is less than the density of water. And let's see what happens. Floats. Floats. And this one also floats. I know the metal ones, they will definitely sink. So I'm not gonna even try those. But I'm curious about those 3. They're pretty light, very light. So I'm going to try and see if they float or sink. Oops. Let me try this one. Oops. And this one. So nylon, acrylic, and PVC, they all sink. So those were the ones that I want to try because they're pretty light. Those, they're metal, pretty heavy. I'm not gonna even try those. So to answer the first question, what determines whether a cube will float or sink in water? Well, if the density is lower than the water, will float, otherwise will sink. The second question, describe how you determined the volume of the cubes. Well, they are all the same, and I just measure each side, and I multiply the length, the width, and the height, and I got my value in cubic centimeter. Describe how you found the density for each cube. I divide the mass per volume for each one of them. So this density lab was as an objective to discover and identify of each cube based on its density, and we did that by divide the mass for each cube by its volume. So you found the density and then you compare with the density of water.